So you want to build a guitar pedal? Well, then you've come to the right place, because this is episode 1 of a 10-part course on how to build a digital guitar pedal completely from scratch. This is not just some course where I will teach you how to make exactly the pedal that I'm going to make, but instead I'm going to teach you all the skills and knowledge you need to take your own custom idea from start to finish. Throughout the course, I will be making this chorus pedal that you can see right here. But again, you could come out the other end with a pedal that is twice as big with 5 times more knobs and your own custom graphic on it. In the course, I'm not just going to show you how to physically build the pedal, but I'm going to show you how to code for the Daisy Seed, which is the microcontroller we're going to be using. I'm going to show you how to make a custom drill layout so that you could have 10 knobs, 2 LEDs, 5 foot switches, and whatever custom layout you want. And then I'm going to show you how to make a custom PCB in KiCad and source parts and look at the data sheet to make your own footprints for KiCad. And then I'm going to show you how to make sure that the PCB will actually fit with the enclosure and the specifications for the drill tool you made. And then I'm going to show you how to make a custom graphic in Adobe Illustrator that we can get UV printed on top of the enclosure, which we've ordered the drill schematic for, so we don't have to touch a single tool. And then I'm going to show you how to assemble everything, solder it together, and then have your own custom pedal by the end of it. All right, that's a lot. So who is this for exactly? What are the prerequisites and tools you should have before you start this course? Well, nothing really. I mean, I made this course for beginners. This is not some intermediate advanced course, even though a lot of the topics covered kind of tiptoe into that territory. But I wrote it so that you could have little to no knowledge and hopefully come out the other end with a pedal. That being said, there are definitely certain walls that you will hit if you have literally no knowledge going into there, so I do intend to have moments where you might need to pause the course and go and learn something and then come back. I would say this course is best for somebody who has just a little bit of knowledge in each category, so maybe you've programmed a little bit or you know some basic components and you understand what like a PCB is or something. But it isn't exactly a fast-moving course, so if you don't know what any of that is, I will still at least tell you what you should look for if you have those gaps. Also, in every description, you will find a GitHub that is linked. This is the course's GitHub repository. In there, you will get all the code that I write throughout the course. You also get the KiCad files that I use and my Adobe Illustrator files. So if you'd like to just make the pedal I make to get started, you can totally do that. I've also included a lot of extra resources that I mentioned going along in the course, like all the parts lists that I buy from Tata Electronics and some learning resources that I've used in my own journey and some recommendations for you. This course is also sponsored by PCBWay, a quick, cheap, and well-made solution for getting PCBs custom manufactured. I'll show you how to order through them later in the course, so stay tuned for that. Without further introduction, here's the first section of the course where I will just teach you all about the Daisy Seed and how we can go about hooking up some basic components. Enjoy. Welcome to section 1. This is going to be the coding section. I'm going to keep all these sections kind of unscripted, sort of just talk and teach and get airs and go on tangents and things without keeping it too long. But yeah, you can always watch it on 2x speed if it's too slow for you. But to start off, I just want to go over the Daisy Seed. This is the tool that we're going to be using to put our code onto within the pedal that'll be generating all the sounds and kind of just the hub for the entire pedal. If you know something like the Arduino, that's kind of what this is, except this is dedicated for audio. You can technically do audio stuff on the Arduino, but it won't be as high quality and there'll be just more hoops to jump through, whereas the Daisy is just this like very nice one-stop shop, high fidelity, and they got great kind of code that you can sort of use this library that we'll see in a sec. This $21 is for this low memory version, but if you want the soldered pins with the full memory, then it'll cost you about $30. And you can go and get it unsoldered and these pins will just come separately, which I typically do because it doesn't really take much time. And the 1 megabyte versus 65 megabytes, this is something they did recently, which is really cool. You can kind of just see here what the sort of applications it would be for. I haven't tried the exact code that we're running today on the 1 megabyte, but for guitar pedals and the amount that you probably want to add, I would just go with the 65. As you see here, this is for like non-bass time effects utility stuff. I had made a couple pedals with that before and it was fine. But so why would you want to use the Daisy? Well, as I said, I mean, you can just put C++ or Arduino, Max, Pure Data right on there. So if you know any of those things, even a little bit, I mean, programming, you don't like really need to know huge C++ or anything, but if you've kind of programmed a bit or done any sort of the visual programming languages, this will translate very, very nicely for you to get to just have examples super quick. In terms of why you would want digital over analog, in my opinion, a lot of it is on versatility and sort of the entry point to create unique stuff. Like you can go online and buy all these little kits to make certain pedals, analog pedals and everything, and those are really nice. But if you were trying to design your own complete unique device from scratch as an analog circuit, you're going to need a lot of experience to be creating things like big delays or these intricate reverbs, pitch shifters, all these things. Even if those will have digital components, which I'll show you in a sec, it still is a lot more to learn, honestly. I mean, electrical engineering is pretty complex, and we'll do some of that in this course, but the bulk of it will be programming, which is also very hard and dense. But you'll see, especially with the Daisy, they have this library that has all these kind of little modules already pre-written that we can do as great starting points. So I think the entry point to the Daisy Seed is incredibly small and good for anybody that loosely has kind of used computers and programmed and stuff. If you haven't too, there's still, like I said, it's not like this super dense programming from the start. It can be that if you want it to be, but it also can stay like this in the same way as you could make some analog little distortion pedal or something, and it can be relatively simple. But I wouldn't say it's simple to truly understand what every single electrical component is doing, and probably if you've just made some kits, you don't actually know that, which is fine. And in this code, you might not totally understand it, but yeah, there's other digital solutions. There are these kind of old little devices that are really cool, honestly, but these aren't necessarily in competition with the Daisy. This is this old, here, let me find a data sheet here that'll say what effects it has. So this one, you can get a chorus, reverb, flanger, tremolo, pitch shifter, pitch echo, and then reverb. And what this is, I don't know when this came out, a very long time ago. This was used in a lot of those like Eventide pedals that you see and stuff. And this would be like if you had this pedal that's probably mostly analog, but you wanted a pitch shifter or maybe the reverb they have, because these are just like completely baked into the chip, and you use these kind of, I think there's this kind of visual software that you can use to sort of program it, which it looks, it's a bit outdated. There's still pedals that use it, but again, like you can only use these. But yeah, you'll see this in a lot of pedals if you go on stuff like Pedal PCB. I'm sure that some use these sort of digital chips. But again, that's not really competing with the Daisy. They kind of serve different purposes because those are just locked in. But they will give that kind of fun, like vintage digital sound because they're really specific and you might actually recognize some of it from pedals that you had used in the past. But yeah, so the Daisy gets you pedals like this. This was one that actually came out quite recently from Glitch Cloud Audio. And I checked into their specifications and stuff, and it was Daisy Seed. I don't know like how, like that doesn't always mean that 100% of it is just like this Daisy Seed in there. But yeah, you see a lot of these kind of modern digital pedals that they're like super feature rich. That's a very like Daisy Seed thing. This company is also by the guy that does that started the Daisy Seed. I think he started this beforehand, Andrew Eikenberry. This is, I don't know if 100% of their stuff is, but they heavily obviously use the Daisy Seed because it's their product too. And you'll find if you start looking in the Daisy Seed, a lot of it, people are doing modular synth stuff. That's like one of the kind of prime things people are doing it for. Here's this other great company, the Synth UX Academy. They have their own synths, but a lot of their stuff is really cool because the point of it is for prototyping the Daisy, not necessarily like a guitar pedal or a modular component or anything, but they do that, like the Audrey 2, which is a really cool device they have. I have a few over here that I'll show you in a second, but they have something like the Simple Fix kit I'll show you is like a really good kit if you're trying to just prototype on the Daisy and you don't want to go out and buy a ton of parts that you might not have yet, and you can just hook that up and use it. Daisy Seed. Here is everything I have made that I kept for myself with the Daisy. Mostly guitar pedals, as you can see in the middle here. And then this is the stuff from the Synth UX Academy that I had mentioned. This is this kind of big synth template sort of thing. This is this touchpad. This is that little prototyping board. You can also get the Daisy Pod, which is Electrosmith's own little prototype board. I think this runs for around like $70. This one's for like 100. These are a little bit more, but yeah, these are all great starting points for if you just don't really want to mess with hooking up a breadboard and everything in the beginning, but we'll kind of go over that stuff later. These two pedals are made with the Terrarium PCB, which is this sort of PCB that you can get on Pedal PCB. I did make a video on this many years ago when I was first kind of learning about it, and I really like this Terrarium PCB because it's so many knobs, so many switches. And yeah, you can check that video out. A lot of the stuff I'll say here is covered in that, but it's just a little more updated, and we're going to be making our own thing instead of Terrarium. But if you're just kind of interested in getting a pedal that you can code on, then that's a great point to do. I have two of those here. This right here is the pedal that I'm going to be making in this course. So like I said, the point of this course isn't for you to make this pedal, but just a pedal of your own design. But I needed a design to do for the course, so that's what I chose, just a 3-knob chorus pedal. And then here is this glove I made. Again, of course, Daisy Seed on the inside, little 3D printed box. And then this really janky wires coming out to a gyroscope that is under the glove, or like kind of inside of it. And then these 3 buttons on the other end. I might make a Bluetooth one in the future and make a video on that, so subscribe for that. And then this right here is a nice prototype board, kind of like these two, except it gives me all this breadboard space if I want to hook up something like the gyroscope or a little LED screen or something, and it has some more knobs and everything. So this is probably what I'll use for this course. I will put this 3D print in the description, the file, if you want to use it yourself. But yeah, these little boxes are really handy when you're just trying to prototype and everything. So yeah, so that's some of the stuff that you can do with the Daisy. It really is super, super versatile, and hopefully your mind is thinking of all these different things that you can make. But for now, in this video, we are going to make a guitar pedal. Before we begin, obviously you will need a Daisy Seed. So if you don't have one, you might just want to go purchase one and come right back. In addition to just the Daisy, you will need some jacks and knobs and stuff to get programming with it. If you have like literally nothing and you're starting from zero, that might be a good reason to get the Daisy Pod that I had showed you. This is a great way to again, just kind of get to prototyping right away. And then once it gets to the other parts of the course, you can kind of return to that once you're more confident, or the Synth UX Academy stuff. But another option is if you're just like, nope, I want to do this whole thing, then you can go and buy actual knobs on an electronics website. This is the one that we're going to be using in the course, Tata Electronics, because they sell pedal enclosures with drill schematics, and you can do UV printing on it. So that's what we'll be using. But you can go here and just search mono jack, because the pedal is going to be in mono. And then you'll see all of these jacks here. I think this is the ones that I have on my prototype board. You can also get ones that hook up to PCBs. They might be able to fit in breadboards. I'm not totally sure. But something like this, if you want to get, and then you can solder on to the pins there, and then on the other end have wires to stick in. I'll show you how to wire up everything. You don't have to learn that if you're unfamiliar. But yeah, in terms of knobs, you could also go the Amazon route if you want to get a big pack. These aren't the types of ones that we're going to be using in the pedal itself. I always do right angle potentiometers for the pedals for space. But this can be good for prototyping, and it comes with caps and everything, so that could also be a place to start for you. All right, done with that. Now I'm gonna assume you have a Daisy and some way to play it. Not hooked up yet, we don't have to worry about that. I can show you how to do that if you're unfamiliar. But yeah, maybe you have a pod or just some jacks or something. But we're just gonna get to flashing some code on it. So you can come here and go to documentation. Daisy luckily pretty recently had redone all of their documentation, so it looks really phenomenal. They have the hardware section, software section, so this is such a good resource. You can just look around and kind of get acquainted with everything. But for now, I'm going to go to software. In this course, we are going to be using C++ to code the Daisy. Like I mentioned earlier, yeah, you can do Max, you can do Arduino, Pure Data, which there's this nice kind of modern version, Plug Data, that can fully integrate right to the Daisy. Rust, there's just all these ways, and like they say, if you are comfortable with C++, they recommend you start there. And even if you're not comfortable with any of these, I would honestly say C++ is the easiest place to start, more because the workflow of actually getting the code on the Daisy It's kind of the most streamlined. It just works really nicely. So yeah, we're going to start here. I'm not going to just fully go over this because as you can see, there's a wonderful guide here and a great video. So I'm going to put links for everything. There'll be a whole documentation on this entire course that you can kind of start, but you just follow this. It's actually very simple. You just install this tool chain. You get the Daisy examples library, which is just on GitHub, and you can clone that. You need VS Code if you don't have it. And now, yeah, we're going to get to flashing, but I'm assuming you've done this now and got that working. They do have some troubleshooting sections if you're having troubles. And I'm also not going to be using in this course the debug probe. I do have one and I definitely recommend you get one, but just since I'm going to assume you didn't get one, then I'm not going to be using mine. So here's my Daisy all set up. This is the breadboard I was talking about if you're not familiar. They're these little prototyping boards, so you don't need to actually solder together electrical components. So if you didn't end up getting one of those little boards, then this is exactly what you want. So I can just stick in these headers right into the board and we can hook up knobs and everything straight to it. But yeah, by now you might have learned, but to reset the Daisy, just press the boot button, which is to the right of the micro USB, press reset and then let go of boot. And that'll just reset your Daisy so it's ready to be programmed or take any code off of it if there was any on it. So now I have this hooked up to my computer and we can go and set up our first project. So my Daisy examples is right here in my documents. This is the repository that you hopefully have cloned onto here. As you can see here, there's a nice helper on how to make your new script. So here I'm just going to type Python 3, and then I'm looking at this line right here. So we do helper.py create, and then I store everything in my projects just like they say here. You might not have my projects from the start, but you could just type my projects / new first pedal, and then we do -- board, and then we are on the seed. Right here, this is meaning like if you have the pod or they have the pedal and stuff, or the patch, then they have some specific helpers for that, but we're on the seed, so yeah. And then over here, you see it actually created my project because mine was normally plural, but that works out. Here is my project. And now we want to come over in VS Code, and don't just open up this C++ file. Like it says in here, you actually have to open up the entire folder so that it has all of its dependencies and things. Let's go to Daisy examples, my project, and then hit open. And now hopefully you will see all of your code and it won't be full of errors. If there is errors, then you might just want to go back through this, make sure that all of your dependencies and paths and everything are set correctly, which I think they have some pretty good troubleshooting listed here if you're having issues. Another thing I like to do that they recommended there just before you really get to start working is you can flash some of their examples on, like the Blink example. So if we just want to open the Blink, I'm going to go back to Daisy examples. If you go to seed here, these are all these examples, and then within DSP are ones that are kind of more like the stuff we're going to be doing for the pedal, but I can go to Blink here. And then as you can see, to flash code on, we want to go to run task and then hit the build and program DFU. And this is important to know if you're just starting off. This error 74 will always appear. That's a good sign. That means you're fine. So don't worry about it. So as you can see, our LED is blinking. Not, the coolest, but it just kind of confirms that your Daisy is all set up and ready to go. So it's a great place to start. I'm just going to reset that though. So back to the new project that we created. You'll see this has a slightly different template that is not the blinking. And what this actually is just feeding the input into the output. So this will just completely monitor what you're playing. But as you can see with my current Daisy, and maybe yours, there's no actual jacks or anything hooked up at the moment. So we have to do that. How we do that with the Daisy is we need to see the pinout sheet. So you can literally just go and search Daisy seed pinout. Click this. I think this is just where you go and buy it. It has a nice pinout. I honestly click this a lot. And then we can see all these numbers with all these different things on it. This is just showing basically where we need to hook up things, like where we'd want to plug in our knob, where we want to plug in the jacks, where we'd want to plug in a power jack or anything. So it says things like, you can see these out, audio out 2, audio out 1, in 2, in 1. So that would be if you want stereo audio, you can see there's 2 ins and outs. We're just going to be using 1 for this, but yeah, and it actually shows it here kind of in terms of programming. So you can see, it seems I can't zoom in, whatever. In 0 and then size. So 0 is going to be this in 1 channel, and then 1 will be our in 2 channel. And then there's all these ADC things listed here, and then D things. So ADC will be for things like knobs, because those have these long analog ranges that they send. And then the digital will be for things like foot switches, LEDs, and everything that are just kind of on and off. So before we get started, one of the first things we'll want to do is to actually hook up the digital ground and analog ground. If you don't know how breadboards work, the plus and the minus are all connected in rows, or not, they're not connected with each other, but the minus is all connected in one row, plus is connected in a row, and then everything else is connected in these columns. So these, 5 are connected, and then everything there is connected. So with the Daisy, you can see on this end, we have 2 little spots that we can put it in the bottom, and then at the top we have 3 options. As you can see, I've also connected the 2 grounds of this one end of the breadboard so that I could connect one ground here and it'll just auto be connected over there. So I'm going to take 2 little wires from a little kit I have that I recommend you definitely get. But if you go on your pinout, you can see the bottom left and the top right are our 2 grounds, so we can just hook those up. And now that should be all good. So first I'm just going to show you how to technically hook up the jacks with a way that in no way do I recommend. But if you're really wanting to get going and you don't have one of the kits or a soldering iron or anything, then this does work, but I expect it to be very noisy. So here I got these things called alligator clips, which you can squeeze and they will open up, and therefore just connecting parts. Basically, you can just squeeze them on pins or components and they will conduct through them. So if I just take our jack here, and you obviously will need 2 for the in and the out, I can connect one like this. So this is with our actual audio pin, and then I need to somehow connect it to there. So I'm also going to get these little jumper cables, but any kind of cable will work. I'm going to connect it to the one end, and then we want to go 5 down, 1, 2, 3, 4, 5, to be in audio in 1. So then I want to do the same thing with the ground pin, and then we can just put it anywhere on the blue row right there. Now I'm just going to do the exact same thing with another jack right here. And then this time I want to go to the audio out 1. You definitely want to make sure you kind of pick the same ones. It would be annoying to have audio out 2 but in 1. Okay, so here's this really janky setup. This is our input, this is our output. All right, as you can see, I have my pocket operator here. I'm going to plug everything in, and as I expected, it is quite noisy. Let's see if we can hear anything. Yes. But now we're ready to hook up our first potentiometer. I'm not going to show you it as in depth as I just did because it's the same concept of what we just did with the jack. But this time, instead of hooking up to the audio ins and outs, we are going to be hooking up to one of these ADCs here in yellow. It genuinely does not matter at all which one you pick, as long as it's one of these 22 to 32 pins or the 35 right here. What a potentiometer is a resistor technically, in which when you turn it, it is changing the value of the resistor. But for us, the Daisy is going to convert all of that into numbers, and we can just easily normalize it from 0 to 1 for when you are left and right completely. Potentiometers, or pots for short, have 3 different legs. The left one is ground, the middle one is called the wiper, and the right one is your power or voltage. The wiper is what we're going to plug into that ADC. On the pinout, the ground pin will go to ground, and the voltage pin will go to this 3v3 analog. So you can pretty much hook the wiper up to any one of these. Like I said, you just need to note what the value is in reference to the pinout. You don't need to know this actual pin number here, you just need to know the ADC 012 or whatever. And then yeah, you'll need to hook it up to the analog ground and digital ground that we had already connected on the breadboard. And then you'll need an extra thing coming out of this 3v3 analog to connect to the right pin. If you have more knobs, feel free to connect however much you want. To start, I'm just going to be using one for a little bit, and eventually I'll have 3 in my pedal, but you can have as little or as many as you'd like in yours. But I will be showing you how to configure for multiple inputs within the code. Congrats on finishing the first episode. I am so proud of you. Hopefully by now you have your Daisy seed set up with a basic understanding of how it works. In the next video, we'll go over how to program a simple distortion and the basics of DSP. If you want to follow the full build, the playlist is linked below. See you there.